Good evening, everybody. My name's Simon Page, and I'm the chair of the IMechE Greater London region. Welcome to this, our inaugural webinar. The format for this evening is a 40-minute presentation and 20 minutes questions and answers. Please submit the questions at the bottom right-hand side, and I will read the questions out. If you ask questions throughout, Tim might pick them up to help aid his presentation. Our speaker for this evening is Professor Tim Baker from UCL, who, unlike most of us, has been fairly busy. Cast your mind back to March, where pupils were still in school and social media, schools and universities were just beginning to close. I had a meeting with Tim, and we were sat there and the universities were closing. I went home to watch TV and put up gutters and do some DIY and keep out of the way. And Tim has a different story. Over to you, Tim.
Hi, everyone. I hope you can hear me, and thanks everyone for joining. So just a quick bit of background. I'll probably describe myself as a bit of an accidental engineer. Never thought I would end up in academia. My background is in motorsport, which will perhaps give you a clue as to the contacts that formed to make this project happen. I ended up at UCL, where I studied purely because I was returning some library books that were actually 15 years overdue, and one thing led to another, and here we are. So what I want to do is just give you a presentation about what has happened in the last couple of months. It's been quite an eventful time. So with no further ado, let me get started. So just to explain a little bit to start with, what is CPAP? You'll have heard in the news, as I did. I sat there on the Sunday morning before all of this started, and I saw that Boris Johnson was talking to big industry, and I sat there and wondered if that was necessarily the right approach for something like this. And I sat there thinking, what if I was doing this? What would I do? And I kind of thought, well, you'd need people who were very quick to respond and have the capability to do high precision manufacturing very quickly. And obviously, with my background, I figured that Formula One would be the ideal to do that. But didn't really think anything more beyond that. I certainly didn't know anything about ventilators. I'm not involved in the medical field, or I wasn't until then. So I didn't have much of an understanding of what the situation was in terms of the ventilators and so on, but just to give you an insight. So you'll have seen in the press about mechanical ventilators. Now, what we were looking at with the guidance from our clinicians was something slightly different. CPAP is continuous positive airway pressure. And what that does is it essentially helps to inflate the lungs under a very slightly increased pressure. And the difference between that and ventilation is that the patient stays doesn't have to be sedated, so they're conscious throughout. It's a lot more comfortable. And as you'll see as I describe it as we go along, there are benefits for CPAP treatment. It's not a replacement for ventilation in any way, but it is part of the clinical pathway. So what is the UCL Ventura? Well, it's a device that we developed between a collaboration between UCL engineers, the doctors at the hospital, and Mercedes-AMG high-performance powertrains. So I'll probably refer to them from now on as either Mercedes or HPP, because it's quite a mouthful, the title that they have. So we were lucky. We were in a great position because these relationships were already formed. So it was a matter of just making phone calls to start with. There was no need for NDAs. Other groups were still talking and trying to get their agreements in place while we were already on the way to developing something. We were very much, I think, different to other groups because we were clinically led. Because we have, as you'll probably see on these slides, they have the logo of the UCL Institute of Healthcare Engineering. And that's who I joined up with as part of the design team. So they were already working closely with the hospital. As this slide shows, we were talking to Italy and China and learning the lessons that they were coming across through treating COVID patients. So what we were realizing was that CPAP was a good thing for treating COVID patients. But at that point, the country was heading in the direction of mechanical ventilation. And also, if we were going to go for CPAPs, there was no supply other than sort of the domestic CPAPs that you might know for treating things like sleep apnea. So what I'm going to do is I'm going to give you a. I think we've all been in that situation, wondering how we would cope with something like this. I don't know. You watch things like Apollo 13 or The Imitation Game, and you always think, oh, I wonder what I would do in that situation. So let's go through it. I'm just going to go through it. I've got a sort of a scrapbook. It's a bit of perhaps not the most conventional presentations, and also I'm still very busy with the project, so I've not had the time to prepare a very glossy presentation. So it's quite an interesting scrapbook just to explain some of what actually happened and how we ended up doing what we did. So Monday the 16th of March. UCL had, by that point, made the announcement that all face-to-face contact was going to be suspended. So our lovely engineering centre was empty of students when I came in on the Monday morning. This is where we have the former student team, Shelley Co-Marathon, the IMechE UAS Challenge, and so on. I bumped into one of my colleagues. This is Tom Peach, who became one of the key members of the team. And he 3D printed something that looked like the shell for a PPE mask, and the conversations, you know, it's a classic corridor conversation of, looks interesting. What are you up to? You know, is that for coronavirus? Yeah, that's what we're looking at. Well, what are the plans? Can I help? Probably could. So I got added to. It started with an email chain, and by mid-afternoon, that email chain had really taken off. A massive amount of enthusiasm, but it was a little bit hard to see where that was going to go. Meantime, a bit of normality. I'm actually involved with the IMechE with the undergraduate design challenge, and I think this was probably a photograph maybe on the Monday, or it might have been the previous Friday, because I had two visits down there, one of which I met Simon. But it just gives you an idea. London was becoming quite a strange place because apart from a few tourists who were left over, it really was emptying. So you were sort of wondering where this was all going to be heading. So I'd already sort of said I could perhaps help with one project. Headed home, and then that evening I was starting to look at details for that project, sort of sitting on my computer, and an email popped up from Rebecca Shipley. Now, she's the director of the Institute of Healthcare Engineering, and I've worked with her previously on a couple of quite interesting medical projects. So she explained that, again, she was looking at the mechanical, or the ventilator challenge, as it was being called. And she was working with another group, and would I be interested, or could I help with my knowledge and experience in design and manufacture? So she was a lot closer to the medical world, and was explaining the situation and starting to mention about how dire the situation was looking. So this is quite late on the Monday evening. I had, for some reason, I took my camera around with me where I went. So these are quite random pictures that are coming up now. But I had to head to my local supermarket. This is literally, it's a 24-hour supermarket. And I thought, well, I wonder if it's true what you're seeing on the news. And sure enough, all the pasta had gone, all the painkillers had disappeared, and most of the toilet roll. So it was heading into the unknown. Tuesday morning, I got up. I told my wife that I didn't know what time I would be home. Headed into London early. This is Liverpool Street, 7:30 a.m. Absolutely deserted. So you could really tell that people were beginning to realise that the situation was quite dire. It's also worth mentioning, I said to my wife, I don't know what time I'll be home, meaning that day, but it was 4 weeks before I actually headed home. So in London, headed back to start having some meetings about what was going to happen. First thing was that my wife sent me this photo and said, this is on our local news. This guy, Chris Buckingham, from a company called Meditech, he said he's been trying to contact the government and the Cabinet Office to offer support because he does respiratory aids for ambulances across the country. and was finding it hard to make any contacts. So I thought because it was local, it was worth giving him a call. And it's funny how these things happen, because Chris was an absolutely fantastic ally right the way through this project. Knew the industry inside out, and was just fabulous in supporting what we were doing. So it's just incredible to look back on it and see where these sort of almost opportunities came from. So we had a few meetings. We had discussions with DFID, which is the Department for International Development, looking at what we could do with ventilators or breathing aids to support developing countries in particular. And by the evening, we were being introduced to, or I was being introduced, because Becky already knew the clinical team. So this is Mervyn Singer. He's one of the intensivists at University College London Hospital. And we sat down with him to start talking through what was going to be needed. So it became clear that what we didn't want was to create a mechanical ventilator, and what we didn't want to do was create anything that was going to be very complicated. So I sort of described it as, what we need to do is, obviously these days nobody can service their car anymore because it's too complicated. We need to go back to the days of carburetors, and he was in very much in agreement. So let's get rid of all the touch screens, let's get rid of all the bells and whistles, and he suggested that we go back to an older style of device that he had in mind, which was very much a passive device that would deliver the sort of enriched oxygen flow to the patient without the need for lots of electronic controls. So this was a meeting that this is where it all happened. The Houseman room, which is where we can congregate as members of staff at UCL. That empty table, sort of in the centre, is where we sat. It was really noticeable that Mervyn and one of his colleagues, Hugh Montgomery, they certainly kept their distance from us, and were already saying that we're going to be in trouble because nobody is keeping their distance. So I came away from that meeting, and it was really quite scary. I found it. I found it hard to take in what they've been telling us. They were saying that within 2 weeks, if we don't have devices based on the modelling that we're being shown at the moment, then the situation is going to be very dire for the NHS. I was also promised that if I did deliver these breathing aids, that I would get a knighthood. So we'll see what happens with that one. Moving on. So the need for CPAPs. Obviously, we were seeing lots of the evidence coming from Italy and China in particular. Mervyn was brilliant because, again, this is where our group was different to any of the other consortia, because Mervyn was in contact with colleagues across the world to find out what was going on. He was asking them to provide not just anecdotal evidence, but was asking for evidence and data so that he could make informed decisions about the direction that we should take. And so he was very clear that developing a CPAP device was the way that we needed to go. So in amongst all of this, I realized that we were going to get involved and do something. So the first thing I did as we headed towards sort of Wednesday, late on Tuesday night, was I called Ben Hodgkinson, who is he's the head of mechanical engineering at Mercedes-AMG HPP. The best way to describe it is that obviously they design and manufacture the engines that power Lewis Hamilton for the Formula One team. I've known him for many years. It goes back to when I sponsored him as a third year or final year student for his student undergraduate project. I gave him his first and second jobs in industry, and then he moved on to what was originally Ilmore and then became Mercedes. And he's gradually risen through the ranks that he's now head, as I say, of mechanical engineering. So at that stage, I said, look, Formula One's going to go quiet. Could you have you got any time to spend with us? And he said he would find out. And I said, could you take a couple of days sabbatical? So what came back from there was Andy Cowell, who is the managing director at HPP. he sent a message via Ben saying, "Do not hesitate to call upon the might of what we can do," which to me sounded, quite exciting, that we could start talking to them about what else they could do. So we moved into Wednesday, and this is the device that we were going to be reverse engineering. So Mervyn and one of his colleagues, you'll be meeting Dave Brearley later in the presentation, but Dave Brearley found some old devices and delivered them sort of unceremoniously in a carry bag to Patisserie Valerie on Torrington Place, where we were all meeting at a lunchtime to decide what was happening next. This is the device. I'll perhaps talk about it a bit later on. It's a machine body, and then it has an oxygen inlet on the right-hand side. And in very simple terms, you can see top left an on-off control, and then the middle button or the middle knob controls the flow through the device, and the bottom one on the left controls the oxygen concentration. There's a circular aperture in the top, and that is the air entrainment port. And so what happens, it's just a simple Venturi device, and as you wind up the flow through the Venturi, it will draw additional air through the entrainment port. So what you have a device that you can control the flow rate, and you can control the oxygen flow. The way it's different to a domestic device is that you can get very high flow rates and very high oxygen concentrations, right up to 100% oxygen if that's what's required. The outlet is facing vertically downwards, and yeah, there you go. So that's a simple device. Now, what's amazing, I needed to grab a picture off Google for this presentation, and unbelievably, this is off. I don't know, it must be off an auction site or something somewhere, because we've got this actual device at HPP. It's got this 89CA and the same sort of almost like graffiti on the bottom of it. So I don't know how that coincidence has come about, but there it is. So that's what we've actually got, and what we started part of reverse engineering. That's one that Mercedes got. I have to say that the devices we got hold of came from the hospital. They came out of a storeroom. And one of them actually came out of there's a sort of a museum of equipment in the hospital, and that's where one of them came from. So the character in the middle, that's Ben Hodgkinson, and this was on Wednesday after the meeting at Patisserie Valerie. It was very exciting, that meeting, because we realised it's such a simple physical device that it's right in it's things that we can do. So there was real excitement that we could actually do something. So we headed to MHRA space. It had all been reconfigured, ready for the reverse engineering. And if you look very closely, I don't know if you can make it out, but the first thing we did, much to Dave Brearley's horror, was that we took the body apart. We took all the valves out, and then we put the body through a bandsaw, not realizing that it was a sort of perhaps a more treasured item from a museum piece. So we started cutting it all up, and these relationships, I've worked with Ben for a long time, so we just knew what it was we were going to have to be doing and what we were going to achieve, and we just set to it. So there was Ben at this stage. Perhaps if I show you the next slide with who is here. And so from on the right, we've got Chris Birkhamshaw, who was from Meditech, then Rebecca Shipley, Dave Brearley. We've got Pete Weston and Ben in the middle, and then towards the left, obviously there's me, and then Tom Peach, who I mentioned, and then this is one of our research students, and I think this is Tom Rushton, one of our technicians. Also not in the shot, we've got a couple of our students who'd recently graduated but heard what we were doing and had come back to help with the effort. So we started the reverse engineering, taking it all apart, measuring it. Obviously, we started looking to see if there were details available. We discovered it was an off-patent device. We tried to get in touch with the manufacturer. We got in touch with the manufacturer, but we didn't get to the right people. Funny enough, the right people have made contact with us this week, saying that we could have all the design data if required. So it might be interesting to retrospectively have a look at that and see how well we've done in copying the original. We've got ourselves organised. The logistics, very important. There's our tea rota, just so that if everyone was making the tea, we knew what was going on. And then we absolutely set to. So sort of from 2 o'clock on the Wednesday, we just carried on. And this is part of the design team. So by 6 o'clock on Wednesday evening, I sort of said to Ben, I think it's a good idea if you lead the design, because I can feel that, you know, I was thinking this will be great fun, me and him working together. But I sort of said, I think the best thing is if I lead it, and if you can totally look after the design, because there's going to be more than just the design of the device. And then he made a couple of phone calls, and we got 3 of the designers from the HPP design office who were quite happy to volunteer, jump on a train into London when everyone was heading in the opposite direction, and come and join the team. And then you've got Alex, who's one of our recent graduates, at the forefront on the right, and then Tom. If you look as well, this is actually early hours into Friday morning. And you can see that we're busy. We're sort of starting to recreate the designs. They're drinking Corona beer. It was strangely, it was the only beer that was left available in the shop. Everything else had been cleared out, but everyone was associating the beer with the virus, and nobody was drinking Corona. So I think that sort of shows the mentality of people. So let's move on. Oh, sorry. I hit the wrong button there. I hope that's okay. On to Thursday. So the next thing is, we're there. We've decided we're going to create a CPAP device, but that's not necessarily any good unless you've got approval to go with it. So Becky was absolutely amazing at working behind the scenes of the politics. We also had David Lomas, who was Vice Dean for Health, Vice Dean for Health within UCL, and they started a really concerted effort to change the opinion within the NHS and up at cabinet level that mechanical ventilators were not the solution. So we had various visitors come along. This is Brian Williams and Nick McNally. They came to see what we're up to, so that they could offer their support to, if what we're doing looks the right thing, that they could offer their support to try and change opinions higher up to support what we were doing. It's also perhaps just worth mentioning at this point that obviously there was Project Pit Lane going on within Formula One, and we sort of popped up as almost as a sideshow to begin with, and so because we weren't part of that consortium, I think we perhaps lacked the credibility initially, but we started making so much noise that it became difficult for people to ignore what we were up to. This was for me, this was a memorable meeting. I'd never met Brian Williams before, or Nick McNally, and it was only just before this photo was taken that someone pointed out that my flies had been undone the whole time. So I think it helped with social distancing. I'm not quite sure, but it's incredible as well how quickly in this period that sort of lasting relationships have been formed. That the normal sort of business etiquette has definitely fallen by the wayside, and we've met some fantastic people as we've been doing this. So the political persuasion was also going on alongside the trying to persuade the NHS to consider that CPAP should be part of the solution. Obviously, I wasn't hands-on that side of things, but what we could help with was with the design data. So on Thursday morning, there was a huge push to get something that looked the part of what we were doing, because discussions were going up through the sort of the political levels, and we got to the point where we were told that somebody would be talking to Matt Hancock on our behalf to explain what we were doing and why it was going to be worth supporting. And to do that, they needed some picture of what was actually going on. And so we were told we need a screenshot of the original device, and as you can see there, this is what they wanted. So we weren't quite ready for that, but it's like, come on, we need it. Let's make this happen. And then before you knew it, it's like, quick, we need it in the next 10 minutes. And we were nearly there. And then suddenly it's like, we've got 2 minutes. And then suddenly we were being told, they're on the phone right now. Where's the screenshot? So we delivered it just in time, and it was available for the discussion. And obviously on the back of that and everything else that we were doing, we started to steer the direction towards CPAP. And obviously, you know, ventilation is just as important, and it plays a very important part. But CPAP can be part of the way. Don't leave engineers to look after themselves. This is another sort of a slightly entertaining part to it. So we worked out that everyone had literally either jumped on trains or got in cars and headed to London. And as engineers, we worked out for the whole group that the number of underwear or the number of pants between us at that point was N+3. So we were in desperate need of having a restock of all our clothing, toiletries, and essentials. So again, don't leave us on our own, because it's about 2.5, 3 days in that we realise that. And I'll show you in a second what the outcome of that is as well. So we move on to Friday. We worked all the way through till 4 o'clock on Friday morning, and headed to the hotel. I don't think any of us slept. Our brains were just, you know, spinning at 1,000,000 miles an hour. And I think if we did get any sleep, it was then the alarm went off and it was time to get up again. So part 2 of why you don't leave engineers to look after themselves, we sent one of our young graduates to go and find what they could in terms of clothing up around the King's Cross and St Pancras. And it turned out, I think we could have had sort of smart suit kind of dress shirts or pajamas, or as you're going to see here, we ended up with these T-shirts. So we ended up looking like we were in a sort of a 2,000 capacity hotel in central London that was virtually empty, just the last few tourists who were leaving. And people took pity on us because I think they just thought we were on a badly timed stag do. But this was the only clothing we could get hold of. The nice thing about this is if you look at the logo and towards the bottom, can you see the name Ventura? So it wasn't any clever name that we came up with to go with the Venturi. It's just that we put these T-shirts on, spotted the name, and that gave us the UCL Ventura name from that point onwards. Friday was all about carrying on with the design. We set a target of trying to be machining within 24 hours, the first parts, and we hit that at the sort of 26-hour mark. Then Saturday carried on with manufacture and producing the first prototype. So here's a nice slide that just shows left-hand side, we've got the original device. Right-hand side, we've got the finished part. Beauty of working with someone like Mercedes is bottom left. We've got a CT scan of the assembly, and then just to show on the right-hand side, that's our CAD version of the final thing. What else did we do? We also had their ability to analyze all the materials. So it's very powerful to be able to do the analysis and know exactly what every material and every component, what it's made from. So that gave us the real confidence. I should also mention, I guess, at this point that getting approval was also quite difficult. The MHRA that do all of the medical approvals, to start with, again, we were just this outsider group, and there was a lot of noise. There were lots of groups all wanting to do things and try and be of benefit. So we were just one of those voices that popped up saying, hey, we've got a device, it needs to be approved. And again, through the political movement and through our clinical team, eventually we got them to start engaging with us. And from that point on, they've been absolutely fantastic all the way with what we've been doing. I think it helps that when we came for approval, Mercedes had produced, I think it's a 128-page sign-off document. And when we were going through it with them, we got to about page 68 with the MHRA, and they were kind of like, okay, we understand it. We can see exactly what you've done. You've totally assured of the quality, and that really helps. You know, we were signing off every single device on the test bed, whereas in normal medical fields, you don't have to do 100% inspection and sign off. For me, I've obviously worked with Ben and with sort of our students. Quite a few of our students have gone to work with Mercedes, and so we know a bit about how they operate. But this is one in particular that I absolutely loved. That they go as far as just doing the drawings for off-the-shelf components, something as simple as an O-ring, and that's because they've obviously in racing they've been caught out in the past where a component off the shelf turns out it isn't what they were expecting. And so this is the attention. It just shows you the attention to detail that they've got. So meanwhile, as this is all going on, we start working on the patient circuit, and we realise that this is going to be just as big a problem because the supply just isn't out there. So this is just a quick, you know, sort of brainstorming all the parts that we need: the pipes, the filters, the valves, the masks, and so on. And we highlighted very early on that was going to be an issue. Oxygen monitors as well. I'll explain a bit later on about oxygen monitors, and you'll see what we did with that. So by Sunday we get to the first test. Here we are arriving. This is the first unit that appears. We park up in the quad. It's deserted, and we head to the hospital. It was quite scary. It was deserted. We've been told previously that if things got really bad, that the doors would be sort of protected by not just security, but then it would be the army. And this may just look like an ordinary photograph, and we all look a bit bored. But this was there was a teleconference going on. I think it was with the director of critical care, and we had to sit in and listen to it because it was about the oxygen supply for the hospital, and it was becoming quite scary. Of you know, if you think now it's become this thing, the new normal, but at that time it was really quite. It really focused you as to what was going on. So we had our first device. We got our patient circuit. This is Dave Brearley on the left. He's the other intensivist. Intensivist is my favourite new word from this project. And they're you know, they are just amazing people. They just through the whole thing so incredibly positive. You might note all the way through so far that you didn't spot much social distancing because we still weren't quite sure of that. We were sort of, you know, touching elbows to welcome each other. We were fairly religious with hand cleaning and sort of hand sanitizer. So we got to the hospital and we plugged everything in, and we expected, I think as Ben described it, it was going to be the big mic drop moment that this thing was just going to work and we'd have done our job, but it didn't. Straight away, it wasn't perfect. We had the benefit of all the testing we'd done, so we knew it couldn't be the device. And I think this is also where having that collaboration really worked, because I think normally if you'd handed over a product like this to the clinical team to go and test on their own, then they'd just come back and said, no, it doesn't work. There are problems. They would have lost the confidence in it. But we were there. The team of engineers was right there and then, and we were able to sort of work out what was going on. So we realised that the hose is all concertinaed, the filters are small, and we soon realised that we needed to improve the flow characteristics of the device. You can see that we tried various different configurations, and as time went by, a lot of the effort then from the device went into the whole patient circuit. So now we have a smooth bore hose, large filters, a mask that gives a very low pressure drop, and so on and so forth. So there's a lot of engineering went into that. We also did a lot of work on the oxygen supply for the hospital, and to show that where they may have issues perhaps with pressure drops and things like that. And as we moved into week 2, this is where we started sort of focusing more of our efforts. Sorry, excuse me. So the team congregated again after our first test. We'd started to get the device working. We'd sorted out some of those teething problems. We were working on a Mark II to improve the efficiency because we wanted to drop the amount of oxygen that it used, having done our initial testing. All smiles at this point. We've got the MHRA documentation. You can see it's quite a sort of a weighty tome. And then we went to start plugging lots of them in to the hospital beds, and we had to run sort of 2 wards worth of or 2 bays worth in a ward to prove that the oxygen pressure did not drop at the supply point. If you look closely, you can see that faces are starting to get a bit more concerned at this point, and I looked like I was really nervous at this point because I was in charge of plugging all the patient circuits together. We had to build 12 of them all together. What I didn't know that I'd carried the whole box of 12 sets of everything, and my colleagues had sent 12 sets of instruction manuals, 12 sets of clamps for the oxygen monitors. By the time I got there, I was absolutely worn out, and it just looked like I was shaking like a leaf trying to put these things together. It's just that I'd lost all the strength in my arms. Anyway, we did all the testing. The data came out fairly good in the end. Actually, you could see there was a marginal pressure drop, but nothing to be concerned about. But again, UCL had the benefit of having a very good oxygen supply. So we were able to start advising other hospitals in terms of what they might face with the supply. I think as an engineer, it's also worth mentioning that our device got put under a lot of scrutiny because it was sort of coming into this environment brand new. And what was frustrating is that we tested against other devices, and we found that ours, in terms of oxygen flow, was very good, and in fact quite close to some of the state-of-the-art devices once we'd done our development on the patient circuit and on the Mark II device. But some of the existing devices are incredibly high flow, but they didn't have that reputation because no one's ever bothered to have a look at it. So moving forward, I think what you'll see is that some of these high flow devices will be replaced by perhaps some of the Ventura devices. Here we go. This is when we'd developed the Mark II. We'd improved the flow characteristics quite considerably, and some of the numbers at certain points, I mean, we've reduced the oxygen consumption at low oxygen percentages by 70%. So quite impressive numbers. Meanwhile, just a few things as we go along. So we're working alongside Intersurgical. They're one of the biggest suppliers of all the patient circuits, and they, just to mention them, they've been an incredible partner to us the whole way. They believed in what we were doing because, again, they were from top level. They had been told which projects to work with, but they appreciated, they understood what we were doing, and we'd sort of gained a reputation and credibility as we went along. I think that's really important to be able to do that. So everything we did was of the highest level. Any of the drawings we were supplying, the bill of materials, to make sure that we made a very good first impression with everybody. Meanwhile, we became members of the honorary members of the NHS, and we had these letters that we could then start moving around if we were challenged when we were out and about. We weren't allowed to go to our hotel unless we were staying there, so we set up a movie room in our engineering centre. And you can see, even the engineers, we've got one of the devices on the bench. Obviously, there's some alcohol, some hand cleanser. And this isn't staged. I came in, the guys, they were wanting to watch Pandemic. What's wrong with them? We were staying in a hotel, as I say, 2,000 capacity, and we were down to like the last 20 people there. We had this whole floor to ourselves, and then we got very, overnight when lockdown was announced, we got turfed out. So UCL were threatening us to put us in a travel lodge. So we ended up in, eventually we ended up in, this is currently my apartment because I'm still living down in London for all of this, and so I've got a nice view of the Regent's Canal, which is one of the benefits. Just briefly, I'll just cover on a few things about the logistics and just on further development. I know I'm just about to, it looks like am I about to run over time? I'm sure you don't mind if I just carry on a little bit longer. It was amazing. This is Camden High Street on a Saturday morning, deserted. It was like living in some sort of zombie apocalypse in central London while all this was going on, and it's quite an uncomfortable time. I think now we've realised we've got more used to it. Into week 3, so we realised that, hang on a sec, we're doing this, and Mercedes are starting to produce, heading towards producing 1,000 units a day, and we're starting to produce oxygen monitors and patient circuits and everything that goes with it. We realised that we weren't even going to have enough space for the number of boxes for what was going to happen. I mean, it wasn't suddenly like, oh no, we haven't got space for everything. We realised this point was coming, but it happened very quickly. So again, I got into my my network of contacts, and I figured that automotive was probably going to be quiet and possibly furloughed, and we were lucky enough to be introduced to GTEM. As it says top right, we very quickly nicknamed them Je t'aime because they were absolutely fantastic. So they opened up their warehouse. They work in the, as I say, the automotive supply chain, and you've got the 3 main characters, Nick, Adam, and Ashley. And what we did with them was, although we were getting the components from Intersurgical, we couldn't. They weren't going to be able to build them into patient circuits for us. So as part of our logistics arm, what we did was we built clean room facilities. We worked with the MHRA again as to what level we needed to achieve, and we had a full assembly line, everybody in PPE. The surfaces are swabbed every twice a shift to check that there's no contamination, and we were then packing and distributing. You can see quite large numbers. In total, we produced 10,000 units. If I'd been told at the beginning that if they'd said in that meeting in the Houseman when it was quite scary, if they'd said we want you to produce 10,000 units, then I think our mindset would have been very different. But because we ramped up to it, we produced 10,000 kits within 4 weeks. So by the 15th of April, we had delivered absolutely everything that was involved. So just to finish off a little bit about whatever else we did, we found that oxygen monitors and oxygen sensors were in huge shortage. So we very quickly managed to sort of grab together pretty much the UK's stock of oxygen monitors for the project, but then that still left a huge shortfall. I think that's the thing that we learned with this project. The whole country, I think the whole world just wasn't ready for this. There was no planning in place, and even in the UK, there are all of these groups trying to get hold of the same equipment. So I think maybe we were a little bit quicker off the mark on all of this, and I'd like to think that we treated everybody with respect, and there was certainly no pressure to do anything, but we did find that people responded to our project, and we did get the supply that we needed. We also looked at not just the device, the oxygen monitors, and the patient circuit. We also did work on masks. You'll have seen a lot about 3D printing and using these types of masks in the sort of COVID situation. Our findings as engineers was interesting. We couldn't find any evidence to support using 3D printed materials in the airway, and also what we found was that these masks, they do tend to have a leakage problem if you're not careful, but that's not anything that's been widely reported as we can see. Again, just going back to the oxygen monitors, you know, we've created from scratch our own, in fact, 2 types of oxygen monitor using automotive technology, because supplies of medical equipment incredibly hard to get hold of. The supplies are being protected in whichever territory they're in, so it's incredibly difficult to get them quickly and at any reasonable cost. So that's why we looked at alternative solutions. This is Tom. Tom, you saw earlier, he became our sort of chief stunt pilot for a lot of what we were doing. So this is testing one of the masks. We also started developing our own CPAP hood. They have a real benefit because it's a lot more comfortable for the patient if they have an intolerance to the mask. You notice that there are two hands holding that hood down, and that's because it does create an upward pressure. We hadn't fitted any straps at that point, but it's quite noticeable the pressure that's lifting that. And then this is the most recent development, working with a company that specialises in, amongst other things, sort of hoods that would be resilient to sort of chemical weapons. That got us into a bit of trouble with the Sun picked up a story at some point because they heard who we were working with and tried to make something out of it. By the way, that's another thing. Our motto all the way along was to keep quiet and carry on. At the early stages, some of the big players were putting out press releases, and there was pressure on us to start telling the world what we were doing, and we figured it was far better to just wait, get everything finished, and a much better, more positive story to then announce when we got the medical approval, which is exactly what we did. And then finally, here's Tom, always smiling, doing the testing. Even when he was checking for things like anti-asphyxia valves, he would sit there doing the test to measure his blood oxygen levels as they dropped, but always with a smile on his face. So just finally, a few slides just to summarise. So the clinical impact. The device got approved and it's been distributed across the UK and the devolved nations and territories and further afield. The impact has been very positive. Across the UK, I think what happened was we got the devices out there across during the peak in London, and then gradually things have subsided, but we've still delivered. Now it's well over 1,000 units across the country. And what will happen, I mentioned earlier, that we'll be replacing some of the high flow devices ready for if or when there is another surge. One of the other nice things we did, we made the designs openly available at no cost. And what's been impressive about that is perhaps if I just flick through to show you the numbers. So it's been downloaded that many times, over 1,800 times across 105 countries. We did a webinar last Friday, and it was incredible just to see teams from all around the world who are making the same device that we've created. So there's quite a list of countries, and it sort of really brings home what we've achieved in that time. Just a quick example. This is devices arriving in Kenya, and again, not the best of photographs, but Mexico were very proud, and they're producing quite a number of them. And then finally, just to recap on the timeline. So we started in mid-March, and first prototype was produced in under 100 hours. We did the patient testing and received the regulatory approval within 10 days, which is unheard of. That's not just because we were doing anything brilliant, it's because they were their doors were open, ready to do things like this. Normally it would take anything up to a couple of years to get medical approval. And as I say, within 4 weeks, 15th of April, we had manufactured and delivered 10,000 units. So I think perhaps compared to other projects, we're unique because we delivered 10,000 units within 4 weeks, and we did it massively under the budget that we were given. So I think we ticked all the boxes. And then finally, just to show you the team that we had, amazing. these are all links that were already made, and that's what made it happen. So there we go. And just the final slide, if you want to find out any more information, we've got contact details there. So that's it. It's not been engineering heavy, but I think it's just nice for you to be able to see the story of what happened. I'm quite happy if you've got any engineering questions, because there was a lot of engineering that really went into it. But you know, it hopefully just captures the pace of what happened. I've lived this surreal life for the last 10 weeks, and it is incredible what you can achieve if you've got the contacts, if you communicate, and if you make sure that you've got the credibility all the way along. There we go. Thanks very much.
Well, thank you, Tim, for sharing with us what must have been a life-changing experience. For everybody that would like to ask questions, if you could submit them on the bottom right-hand corner, I'll read them out to Tim and then he'll answer. Please, could you keep them fairly concise? And Tim has asked that there are no questions of a political nature. I'll start the ball rolling. How long did it take you to get medical approval, Tim?
So yeah, as I mentioned, from the start of the project to the actual approval was 10 days. As I mentioned, it's very difficult to get them to listen to us to start with, because we weren't recognised as being part of the ventilator challenge or any of the other groups. But it's through the stubbornness, the persuasion of the rest of the, if you like, the non-core engineering team behind the scenes. I mean, I didn't even realise that all of this was going on until several weeks further down the line, just how much work they had to do to get them to listen. I think there are always sort of chances, bits of luck that happen. And it turned out that we had somebody who was working at Mercedes who, I think it might have actually been a relative or a partner who worked for the MHRA, so they were able to go and tap on a shoulder as well. So people were hearing about us from all directions, so that they couldn't ignore us. We did a lot of groundwork, so once we started talking to them, we found out, you know, the hurdles that we needed to overcome, and then we could get the submission in. For sure, you know, there was a fair bit of backwards and forwards, but it was from start to finish. It was 10 days. I don't think that record will ever be broken.
Next question from Andrew Tripidi. What aspects of the device were influenced by physician input? Was there a need for any change to the device that were initially distributed?
Sure. So again, this is the big positive of our group. It was led by the clinicians, so we were acting on what they wanted in their hands. So that's why we chose the whisper flow to reverse engineer. The early testing showed that we could do something to improve. If we could do anything to improve the oxygen use, it would be of great benefit. So what we learned was that every part of the patient circuit, every bit of the pipe or the filter or a valve, that creates a pressure loss. And so we worked very hard in development. We did a lot of testing of lots of components to reduce each of those pressure drops. Apart from that, what also happened was HPP, they did a lot of simulation work, they did a lot of bench work to improve the device itself. So I think it's quite nice that obviously they know a little bit about airflow and efficient airflow. So they developed the air entrainment port and the sort of the throat of the Venturi to improve the flow characteristics and reduce the losses. And that did, with the patient circuit, created, you know, a massive gain in efficiency. If you look at that picture that's on the screen now, that's a Mark 1, and it had the very square-edged port. We stuffed a filter into that, which in itself had a pressure loss. And if you look at the regulations for medical devices, I think it's IP22. Essentially, as long as you don't get your finger stuck in there, that will be adequate. And then we had a filter just downstream of it. If you look at the Mark II device, it has almost like looks like a mushroom over the top of it, and that is shaped to entrain the flow more efficiently which gave the improvements. So they were the major developments. Even silly things like the off-the-shelf oxygen sensors. They pretty much stuff the nose of the sensor to block sort of 2/3 of the airway of the pipe, so that's one of the first, one of the easy wins was to improve that. I think you've also got a situation where in sort of value engineering all of these parts, because things like the concertina hoses, you can't deny it packs beautifully in a box, and then you can just stretch it out to sort of 2 meters in length when it's in use, but for flow it's not very good. Things like that. So we found there was quite a lot that we could improve.
I think you've answered part of the question from Tim King on how did it work on the wards. How many were actually used?
How many used? Good question. I think because that then goes on to the clinical data. We don't get to see that side of it. We just know how many we've distributed out to hospitals. But we've had quite a lot of data back from hospitals all around the country who have been using them, and the results have been very positive.
Two together, one here from Brian Gleeson. Would you be able to expand upon the Mercedes-designed oxygen sensor function? And another one from Tim King in a similar vein. Not clear how the pressure oxygen levels are reported. Is there a display?
Yeah, sure. So the Mercedes didn't do the oxygen sensors. That was done with two companies. One was Oxford Optronics, who specialise in medical products, and the other one was a company called Life Racing, who specialise in motorsports control electronics. So they both made their own oxygen monitors from a standing start in a similar sort of timescale. So what you do is that goes into the patient circuit, and it just has a simple LED display or a small sort of LCD display, and that just shows you the oxygen entrained in the airflow as a percentage, and it just has simple high and low alarms, so you can set those, and it'll set a buzzer off if it goes out of range. In terms of the pressure. So this continuous pressure system, what happens is you just have it's a simple diaphragm valve on the exit from the mask of the patient, and it's typically set at quite what seems like quite a low level of 10 centimeters of water, and the system delivers that 10 centimeters of water continuously during breathing in and breathing out. And again, not all of these valves are the same, because although they respond to the pressure, the flow area that they have, especially at high flow rates, can become restrictive, which then puts more back pressure through the system. So that's something that we learned quite a lot about. To set those, you'll see perhaps on some of what you've seen on news reports that they tend to have a little plastic manometer that just a diaphragm, which is it has a small amount of leakage through it, and then that just flutters, obviously depending on the pressure, and that varies by a couple of centimeters of water during the breathing cycle. So that's how you set the pressure. Then there's a higher level, essentially a pressure relief valve in the system, so that just protects the patient's lungs. If you have a go on one of these things, as engineers, 10 centimeters of water, you think, well, that's hardly anything. But if you breathe against that, it is you notice it. It'll make your ears pop. Put it that way, more times than not. And we also found that when we were trying to, part of what we were doing was trying to reduce the oxygen flow, but at the same time, if you had all of these back pressures and you ended up having to deliver a high flow rate, overcoming them, then that becomes more uncomfortable for the patient. And when they're trying to breathe out, they're having to fight quite a high flow rate of oxygen. So that's a little bit, about setting flow rates and so on.
Really good question here, Tim. Where did the budget come from?
good question. That came from the Department for Health and Social Care. We loved the way that they worked in that respect. I mean, we've seen the inner workings. We had every 2 days we had a meeting with a representative from the Cabinet Office, and there are some absolutely fantastic people involved. I think the systems that they work within are leave a lot to be desired. But coming up with the budget, we had an online meeting, and they said, okay, we're going to go ahead with this. Let's have a think. We've got what? Let's say we've got 250 hospitals. Let's say we're going to send 40 to every hospital. What does everybody think they can deliver their parts for? Okay, let's put a small markup on that to cover everybody's overheads. And that's literally how the conversation went. We agreed a multi-million-pound figure, and a simple contract was drawn up, and we went and got on with it. So that side of it was very refreshing, how quickly things like that could happen. But on the flip side, anything to do with the supply chain within the NHS was unfortunately very frustrating. Again, great people, but I think they have to work within systems that don't necessarily do what they should.
So we're out of time there. Tim has agreed to carry on asking questions, so we'll carry on shortly. But I'd just like to say at this point, thank you for everybody for attending. And that's the end of our time. But we'll carry on with questions from Tim. Next one here, Tim. Keen to know what sort of changes were done to the Mark II to achieve higher flow oxygen.
Yeah, sure. I think I've probably covered that already. So that was the around the air entrainment port and the venturi itself. So the entry to the venturi, that was the main part, and then obviously all of the patient circuit was what happened.
2 questions together here, Tim. Who owns the IPR for the original device? And there was an earlier one, which is why was it no longer made?
Yeah, so the original whisper flow, I think, went out of use probably about, or regularly, probably about 10 years, 15 years ago, something like that. So again, we tried really hard to get in touch. It's a real shame. We must have been so close to talking to the right person to get, the obvious thing was just let's go and make some more of the same thing, and let's just make it quickly. But we never quite connected those dots, unfortunately. So again, we were going down the route of not making anything too clever, too complicated. It's a simple passive device that doesn't take a massive amount of training to be able to use it. I think we probably made with Mervyn and Dave Brearley advising that I think we made a good choice of what to do.
There's a question here from someone in Iran. If you look at the last presentation, which will be up earlier, Tim's provided the links, and could you contact him through that if you need further input or information? Another question here: do the units require any preventative maintenance during operation?
They don't. No, they plug in. You can either plug them into the wall supply, or you can plug them into a hose so that you can sort of mount them on a pole. Then, in terms of maintenance during operation, I mean, they change the filters quite regularly, obviously. But beyond that, there's nothing significant that needs to be done. In between patients, then obviously they get they don't get full sterilization as such because they are protected by filters, but they are cleaned down with Clinell type medical wipes to disinfect them, and then they'll be good to go again.
Another question on the cost here, Tim. Was there any consideration on cost, which you covered earlier, and did you actively carry out any value engineering even within the short timescales? I think that's quite a pertinent question to most engineers.
Yes. So again, I was in control of the budget, and the first estimate was completely based around, literally Mercedes doing their estimates of what the manufacturing cost would be. Same for the oxygen monitors, and us working with all the parties to make that agreement. The way it was done with the DH was it was an entirely open book exercise. So that was right the way through. We could share that information with them, and likewise, all of anyone we were working with, we did the same agreement. And you can see that in terms of value engineering, as the process has improved for manufacturing, you've got 10,000 to go at. You can get better at it as you go along. So gradually, the price did start coming down. In terms of sort of materials and that sort of thing, we were a little bit fixed in what we were going to use. Again, when this started, I mean, it was absolutely, you were on a war footing. We were working absolutely all hours of the day to achieve this. Mercedes were just working 24/7 shifts, and so we certainly didn't have the luxury of shopping around, say, for whoever was going to be the cheapest supplier of materials or anything like that. It was more a case of have they got a secured supply, and can we purchase it? We had that a lot of the time. As I say, things like oxygen sensors. The world had a huge shortage of them, and then when you find out that the Americans are one of the biggest manufacturers and they're not going to sell them to anybody, you realise that you've got problems. So, in ordinary times, for sure, you could get cost out of something like this, but at the same time, it really was more a case of can you get your hands on it. Having said all that, I think that obviously I can't share the financial figures, but I think what we came up with was incredibly cost effective.
Several questions here, Tim, around manufacturing limitations that had a significant impact, and did the experience have anything that improved the turnaround of the design and manufacture projects? Are there any lessons learned from the projects that you can apply elsewhere?
Good question. I'd say that the best advice for what we've learned is we did this because we had ready-made relationships to tap into. I think it'd be interesting if there's anyone listening to this who knows me from when I was at university. I was always the very quiet one, and I think sort of engineering gave me a voice, and so I've built a large sort of network of people that I've always kept in contact with right the way through my working career. So when this happened, I could pick up the phone, and I spent all this project quite honestly talking to people. So I'd say that is so important. What else did we learn? One of the nice things that we did was I've been trying to teach our first years how important it is to have a good bill of materials. I'm involved in the IMechE, the Undergraduate Design Challenge, and I wanted to introduce that to them this year for first years. So a couple of them, they helped me develop a really nice template for a bill of materials, and then lo and behold, obviously it's a shame they all had to leave and head home. But the first thing I did is, because it was such a nice template that they made, I picked that up and I ran the whole project using the template that a couple of our students had built, and we put that together with help, from industry and from previous experience and so on, and that works really well. The other thing that I'd say is that if I sort of intentionally delayed sometimes releasing information, things like assembly drawings of the patient circuit or technical details, until they were absolutely spot on. We're only talking a few hours or something like that, because credibility, I always say, you never get a second chance to make a first impression, and in this environment it was really important. And I think that approach really worked, because people were saying, well, who are you? and then when they saw the quality of the information that was being presented, I think that helped to open doors. Obviously, again, in everyday life, that sort of is a normality, but it's important. I think it really showed the importance of doing things properly, and I think that probably gained us credibility when we were having to fight for the attention. So hopefully that helps a little bit. What else have we learned in terms of the manufacture? I mean, it's just incredible what you can achieve with this would never have happened. Here you go. This is what we learned. One of the things I said right from the beginning was, okay, we're going to have to take a risk with this. We are going to have to be in an office together, face to face, because it needs. You know, everyone won't be sitting there at 4 o'clock in the morning at home working in isolation. It needed everybody together to have that creative energy and the spontaneity that goes with it. So that's something that we knew we were taking a risk with, but we soon got into, we were living in a sort of quarantine between where we were working, a short walk to a hotel, and then back again, making sure that we weren't sharing facilities. We were very clear that we in terms of sort of eating and that kind of thing, we were very, very careful of sort of the hygiene side of it. So that was really important. So the collaboration, email. This wouldn't have happened. I mean, I had to once we did the first press release, my email was useless because it just got absolutely sunk. I mean, everybody was very well intentioned, but just getting this wave of noise from people was honestly, thousands of emails have been through my inbox as a result of this, and that didn't help anybody. So it proved just how important. We couldn't do face to face, but a lot of telephone calls, lots of Teams and Zoom and that sort of thing, and that instant communication is vitally important. You probably tell I'm not a big fan of email, and I don't think it would have worked in this situation. Email just for confirming things. So yeah, having that creative spark together is really important. So that's one of the other ones. They're what spring to mind.
A couple of questions here. How many different companies were involved? And do you have any further collaborations with the likes of Mercedes planned?
Yeah, sure. So again, I'm still only going home at the weekend. So although we delivered on the 15th, we're still doing the CPAP hoods, and we've got things like we're doing an electronic manometer to help with setting up patient circuits, all sorts of bits and pieces. Dentistry is another area we're having a look at, because now people have heard what we've done and achieved, that there's other projects that they wanted to collaborate on. So in terms of the number of companies, if you think about it, so the main ones we had sort of Mercedes, there's UCL, there's the hospital, there's G10 with logistics, and then you've got the two suppliers of the oxygen monitors. But then there's a whole pyramid below them of all their suppliers. So they were each, working with the supply chain amongst that. Actually, one of the things I'd like to mention, I got in contact with the Gear and Tool Makers Association and the Motorsport Industry Association at the beginning of this, and they were brilliant at helping us to they compiled, they put call outs and then helped compile lists of companies that were willing to help us, because trying to get this going in a lockdown was another challenge to overcome. That let's go and make things quickly when a lot of people aren't actually at work, and getting them to open up and do that sort of thing. So there's lots of companies. There's so many people that have helped with this. We're just like the focal point of it. And I mean, I probably will carry on in some capacity with what we've been doing with the Institute of Healthcare Engineering from here, and with Mercedes. And with Mercedes. I think they have expressed an interest to, and we are still doing some bits and pieces with them, but still to carry on.
how difficult is the final design to manufacture? Does it require the capabilities of an F1 engine manufacturer?
No, it doesn't. It was done so they did it with that in mind. So it doesn't need 5-axis manufacturing or anything like that. It does need CNC, 3-axis milling, and it does need. I mean, you probably could do it manually, but you know, there is an expectation that will be a level of computer controlled manufacture for it. So it can all be made in a fairly conventional machine shop. Obviously, I'm sort of saying that in terms of then if you start looking at developing nations, then it does become more of a challenge for sure, but certainly not impossible. I think perhaps some of the drawings have got what you might describe as F1 tolerances on, and that might be a challenge for some people. But what we say in that case is that you know, we release the designs and then they can make of them what they will, so long as they get their own. You know, they don't get our approval that goes with it. They have to go and seek the approval of whichever regulatory body that they work with.
How did you sense the pressure and detect breathing waveforms to sync the ventilator with the patient?
Okay, well, the beauty of CPAP is it's all it's a conscious patient, so they are the demand. There are no control systems at all. So this is why it's become a very, very powerful technique to keep patients from having to go onto full ventilation. So there aren't, you know, there's no controlled, as you get with a ventilator, there's no sort of, you know, tidal flows or breathing rates or anything like that.
In a similar vein, Tim, how much inlet pressure does the device require, and can it be supplied by 1 atmosphere?
Yeah, no, it needs. All hospitals have a 4-bar oxygen system, and it needs that 4-bar system. So it really does rely on a sort of a typical hospital oxygen supply. You can theoretically run it from a large oxygen cylinder, but the issue with that is that you would be changing the bottles so frequently that it would become impractical. And I ought to just add, that's not because this is a high flow device. It's just that patient demand is high with any sort of breathing device like this. We've also looked at oxygen concentrators, and that's something that might happen going forward. But then you've got issues where for instance, the World Health Organization has sort of approved the use of an oxygen concentrator that has too high a flow rate. Sorry, the flow rate is too low to support any type of ventilation or CPAP device. So it's kind of, this is perhaps a little bit where, I don't know, whether you describe it as politics or you know, the practicalities aren't quite there for devices like that. So what we've been looking at in terms of global supply is most countries will have hospitals in major cities that will have the oxygen supply that's needed.
Okay, I think that's about all we have time for. Thank you ever so much for telling us your story, Tim. There was one other thing there, one other question asked. Will the files be up afterwards? Yes, we'll share the recording afterwards. Yes, thank you very much, Tim. An incredible story, very interesting, and what must be life-changing in terms of what you do. One final thing, what will you remember the most?
The pink T-shirts. What will I remember the most? Crikey, it was very intense. It was, I've made some friendships that are going to last a lifetime from And some of these people I've not actually met yet. They've all been online, so it's still not sunk in yet. I've got to be honest. It's still going to take time from here to digest, because it's still sort of 14-hour days at the moment, but that time will come.
So thank you very much, Tim. Just to let everybody know, we have 2 social media accounts where these things will be published on. We have a Facebook, a LinkedIn and Twitter account. Our upcoming events are on the 8th of June, Industrial Applications of Structural Dynamics, and on the 11th of June, Patents for Engineers. Thank you all very much for attending, and stay safe.
Yeah, thanks everyone.